My name is Ali Sebt with the Sebtronix Business Group. I have been working in a consulting capacity with Nuvoton with the goal of developing an end-to-end secure solution for embedded applications targeted at building automation systems and other applications like building automation systems. Today's presentation is focused on delivering peace of mind for IoT embedded designers based on a new secure end-to-end reference design that we have developed along with Nuvoton and our ecosystem partners that can be used by embedded designers and Nuvoton customers to achieve end-to-end security. IoT and security are a very hot topic these days. And of course, we know embedded designers are experts in what I'm calling operation technology or OT. Embedded designers are excellent at designing safety machines or safety applications, controlling sensors, controlling actuators, devising very sophisticated power management schemes for embedded machines, as well as designing machines that can operate for very long periods of time with various power management modes. With the proliferation of IoT, however, these connected machines and their operation technology functionality are creating vulnerability for IT infrastructures. And let me talk about that. You see, embedded designers and the embedded machines that they develop support various infrastructures. In this case, a building infrastructure is supported by an HVAC machine, security cameras, elevators. Of course, there's motor control and connectivity in elevators, parking control, fire and safety equipment, thermostats, and environmental control, UI machines, access control. And all of these embedded machines that support infrastructures, whether it's a university campus or a hotel or a commercial building or an apartment building, retail, these equipment are referred to as operation technology. And unfortunately, they have become the #1 target of cybersecurity hacks and hackers because, typically speaking, they don't have much in terms of security. And this is the essence of today's presentation and how this Nuvoton reference design and solution is going to address this vulnerability. There are thousands of vulnerabilities every month. I'm going to share with you two highly visible examples that have been in the news over the past decade, although there are thousands of them. One, back in 2013, a famous and big department store was hacked through a mechanical contractor that this big department store had hired to manage some of their equipment, such as their HVAC system. And hackers were able to detect a vulnerability in this third-party contractor's credentials, and they're able to hack into the IT infrastructure of the department store and steal literally millions of customer credit card information. And as a result, there was a huge financial liability for this department store. In 2018, there was a casino lobby connected fish tank thermometer that was hacked, where hackers were sitting in a casino lobby and they were able to hack into the thermometer that was in this magnificent fish tank. And this thermometer was connected, obviously, to the IT infrastructure of the casino. And by hacking the thermometer, which lacked adequate security credentials and security protection, they were able to get into the IT infrastructure and steal droves of customer information. In fact, when we look at psacertified.org, this is an organization that has that's primary goal is to devise schemes for IoT hardware, software, and devices to provide security solutions and security schemes. When you look at their website, they claim that on average, there are 5,400 attacks per month on IoT devices with 7 million data records compromised daily. And they further quantify these attacks to amount to 330,000, or the average cost of an attack is over 330,000. And the future, the cybercrime damage by 2010-25 is going to be just staggering. So as embedded designers, developing machines, OT machines that are connected to infrastructures, we have to take into consideration these challenges. So when we look at IoT and security, unfortunately, some embedded designers believe that because their machines have never been hacked, then their systems work just fine. But this is like driving a car without insurance. Of course, you're fine until you get into an accident. Some embedded designers rely on the security of the transport layer. Once the data or the intelligence from the machine is transferred over cellular or Wi-Fi, then indeed the transport layer provides security, but that's after the data has left the machine. The challenge or the problem is when the machine is collecting the data and deriving intelligence from that data. So the opportunity is to secure the data and the intelligence at the machine or the device level before it's sent out. And if we do so, this will protect everyone in the value chain. As I mentioned, in the case of the department store that was hacked, the third-party contractor also felt the pain of this massive cybersecurity attack. So by securing embedded machines, we not only protect ourselves, but also protect our clients and everybody in the value chain. We know infrastructures, as I mentioned, it could be hotels, university campuses, commercial buildings, retail stores, shopping centers. They're adopting IoT at a rapid pace. IoT helps with energy savings. IoT helps with being efficient in terms of space utility, in terms of many cost savings and many other benefits. So IoT is here and growing at a very rapid pace. And when we look at this diagram, typically embedded designers have sensors spread all over and they take advantage of the sensor data, whether it's motion sensor, environmental sensor, air quality sensor. And the data from these sensors is turned into some form of intelligence via the HVAC machine or the energy equipment or the elevator. And that intelligence is transmitted into the IP network and the IT infrastructure of the building. The barrier to entry has been this fuzzy environment or this rather barrier between the OT domain and IT domain, meaning embedded designers build these machines that do a phenomenal job in the operation technology domain, but properly connecting them and ensuring secure connection through the life of the device and the connectivity to the infrastructure is the challenge and the barrier to entry. In fact, when we look at these two domains, the IT and OT domains are typically integrated at the cloud level using various cloud applications. So with that, what has become known in the industry as this integration of the IT and OT domains is referred to as a device lifecycle management, also known as DLM. And there are typically 5 steps on average with device lifecycle management. The first is onboarding, where the cloud infrastructure of a building or any entity would first properly onboard an embedded machine that's going to be connected to that infrastructure, that is going to perform some operation technology work. Let's consider a new HVAC system or a new thermometer that's going to be attached to a building. So the first thing to do is to properly onboard that machine with the proper credentials. The second is to configure that machine and control that machine to work in the way it's intended to work in its environment. The third step of DLM is to monitor the machine on an ongoing basis, probably send alerts or monitor for diagnostics information. So if a machine needs repair or maintenance. And the fourth step is to perform that maintenance. And in many cases, it means over-the-air software and firmware updates. And finally, when the machine has done its job or reached its end of life, or if it has been compromised, the infrastructure, the IT infrastructure wants the capability to be able to decommission or sunset or kill that machine in case it's been compromised and hacked. So these are the 5 steps. In fact, I'll use a consumer example to talk about these steps. Nowadays, when you buy an exercise machine, most exercise machines are connected to the cloud and they come with some subscription model, a monthly subscription model for the type of classes that you're interested in enrolling in. So when you first buy the exercise machine and connect it, to the cloud, if you will, the first thing the cloud infrastructure, the company that sold this bike machine is going to do is onboard the bike and make sure it's a legitimate bike, make sure it's one they have sold. And then they will configure it for the type of, let's say, monthly subscription model or classes that the customer or consumer has signed up to pay for. So that's very important, so that the bike will only function in the manner that it's being paid for. Of course, on an ongoing basis, there are sensors on the bike that monitor its performance, and if they sense the bike is not performing well or needs to be maintained, those alerts will go to the consumer. And then from time to time, they might want to send software updates because of security updates or functional updates. And of course, finally, if the customer doesn't pay their subscription, they might want to end its functionality, decommission it, if you will. When we look at the IoT infrastructure I was referring to earlier, the building infrastructure, for example, Nuvoton has devised a secure end-to-end IoT reference design to really make these onboarding steps or these DLM device lifecycle management steps very easy for embedded designers. You see, many companies that develop embedded machines, as I mentioned earlier, are excellent at controlling actuators or reading sensor information, but they don't necessarily have the resources or the expertise to do security, to connect to the cloud in a secure manner, to exchange keys, to encrypt the keys, and to ensure a proper method whereby the user of these machines can interact with these machines in a secure manner. So this reference design is intended essentially to simplify those secure provisioning. So those DLM steps or provisioning an embedded machine is very complex, and this reference design's intent is to simplify the provisioning of embedded machines. What you see on the left are the different components of the reference design, and I'm going to go through them one by one and explain what they are, and then go through the functionality of this reference design. So let's first talk about the components. First and foremost, Nuvoton partnered with a global IDH ecosystem partner called DonorWorks, located in Michigan, United States, or Grand Rapids, Michigan. And they are an excellent independent design house with a very wide spectrum of engineering skills, all the way from complete device to cloud development, secure development, secure embedded technologies. They develop FDA solutions, and of course, experts in FPGA. So Nuvoton partnered with DonorWorks to develop this reference design. And at the core of this reference design is the Nuvoton NuMicro M2354 Secure MCU, which is rich with security features, including it has the ARM Trust Zone, it has key store, and of course, a cryptographic hardware accelerator to help with encryption of the data and the keys. Next, we're using the NuMaker IoT M2354 board. It's a very all-encompassing, it's an IoT board with lots of great features. It has in it, of course, on it the M2354 Secure MCU, an environmental sensor, a LoRaWAN solution using a Semtech radio. It offers Wi-Fi via an ESP module, Bluetooth, and of course, Nuvoton's NuLink onboard debugger. Next, we have developed a mobile app for provisioning. This mobile app is available both on iOS and Android stores. It's used initially for onboarding of the machine, as well as authorized installers and users. So when you're installing an HVAC machine or a thermostat or any consumer gadget like the exercise box, so this reference design, while its intended initial use is building automation systems, it's developed in such a way that embedded designers can use it for a variety of applications, not just building automation. So onboarding, this app is used for onboarding of the machine as well as authorized installers. A lot of times it's the installers or the users that misuse or don't properly use machines, and these machines become easily hacked. Of course, it enables provisioning of the devices to the cloud and some device management functionality. For this specific reference design, we are using a Tectelic LoRaWAN gateway. Of course, it has integrated cellular solutions and Ethernet backhaul, and it provides various frequency bands for various geographic regions around the world. And for cloud, where the keys, the key management, and the cloud type of applications, we're using AWS IoT Core for LoRaWAN, as well as AWS Cognito for establishing users and user management. Finally, there's the mobile app is also used to display sensor data, again, both on iOS and Android stores. And in this case, because the IoT board that we're using from Nuvoton uses an onboard environmental sensor, we can measure and display temperature, humidity, and pressure information. So let's now unbox this. And one of the first objectives that we focused on was to provide a really an excellent out-of-box experience for designers who receive this reference design. We wanted to make it very easy in terms of setting it up, because the objective is to enable designers to focus on their application and not really focus on provisioning and security and connectivity. So I am going to take you through the steps that provision and connect any machine that you want to design to the cloud, and you'll see how easy we have made this. So let's go through the out-of-box experience. First and foremost, when you power up the machine, the reference design, in this case, the device will come up in BLE broadcast mode, and you'll use the app to scan for the device. Next, the app will connect to the device. And then on the app, you'll select the type of provisioning keys that you want to get from the cloud server. Once you have selected the type of keys you want, you make the request. So the app will make key requests from both the network server as well as the application server. Then the servers will generate the provisioning keys. Once the keys have been generated, then the application server will link the device to the user's account. This is very important. If you remember, I talked about installers and talked about users. So if you want your embedded machine to provide the level of security where you can ensure the right user is using the machine or the right installer is installing the machine, then at this stage, this is where the application server is linking the device to the user's account. Then the server will send the provisioning keys back to the mobile app. And of course, at this point, the app will transfer the provisioning keys over BLE to the device itself. So what we've done right now is we have used the app to request the provisioning keys from the cloud server. The cloud server has in turn generated those keys, linked them to the user, and sent them back to the app. And then the app basically will transfer these keys to the device. Now, the device, the first thing it will do is it will use the key store, the vault that comes with the M2354 Secure MCU. It will use the key store to store the keys. And then the LoRa MAC will leverage the crypto accelerator that's on the device to basically take the sensor data that the machine has gathered and collected with whatever other data and encrypt that sensor data both with the app key and the network key. Then it will transmit this packet over the LoRaWAN radio, which again comes with the reference design. And then the LoRaWAN gateway will capture this packet. And of course, at this point, then the AWS IoT for LoRaWAN server, which will receive this from the LoRaWAN gateway, will decrypt the packet with the network key and then parcel the packet to the appropriate applications. And of course, in this case, our application, the mobile app application, will use the application key to decrypt and use the data that was captured by the device. So a very easy provisioning experience. If you're designing an embedded machine and you want to connect it to the cloud and you want to ensure there's end-to-end security, as I demonstrated in these very easy steps. And of course, once you see the demo itself, this happens very rapidly. I mean, in split seconds. You know, you're requesting keys from the network server. These keys are generated. They're linked to the user. They're sent back to the device. The device stores the keys in a vault in the key store. Then it will use the onboard cryptology crypto accelerator to encrypt whatever data the machine is collecting with the keys. It will encrypt them, lock them up, and send them over, in our example, in this example, a LoRaWAN network back to the cloud. You can use Wi-Fi or any other connectivity mechanism that your machine is designed for. And of course, once the data is decrypted with the application key, in this case, temperature, humidity, and pressure, it's displayed on the mobile app of this reference design. Again, we designed this reference design from the get-go with the intent of providing an excellent out-of-box experience for Nuvoton customers and embedded designers. The firmware, the instruction guides, and everything is readily available. And this reference design is now available for customers to take advantage of. We went a step further, and what we did was we said, look, let's design the firmware that comes with this reference design that does everything I talked about, requesting for the keys and getting the keys back and encrypting the keys. All of the firmware, let's design it with a production quality mentality in mind so that customers can take this as a starting point and integrate it into their own application and build upon it with whatever unique features or whatever unique ways they want to implement it in their design. But the key point is that this is not sample code. This is not example code. It's really quality code that is intended for customers to use as a starting point for their own end design. And by doing this, essentially what we've done is we have removed the barrier to entry for many customers who don't have security designers, who don't have security engineers, who don't have provisioning engineers. We've removed the barrier to entry for those customers. We have reduced the total cost of ownership by developing these apps and by developing this production firmware. And of course, once you use this and focus on what you do best, we will improve your time to market. Additionally, as part of our ecosystem, as part of Nuvoton's ecosystem family of network, we've also partnered with Data.io, who's a global provisioning leader in terms of silicon device programming and provisioning. And what they have done masterfully over the years is IoT security deployment as a service. And their Sektronix machine and all the software world that goes along with the Sektronix machine essentially delivers a very secure and efficient system for customers to be able to deploy their firmware and data and secrets in both IoT and automotive devices in high volume. So once you have used the Nuvoton reference design to achieve your proof of concept, to validate your design, and you're ready to go to production, we have also partnered with the proper high volume provisioning partner to ensure that you can go to production in a very secure manner. Remember, I started this presentation by talking about the objective is to provide peace of mind for IoT embedded designers and their value chain partners. In fact, once these concepts are deployed in your embedded machines, first and foremost, you will achieve data security. That means you can protect your core assets. So when you encrypt your data and whatever intellectual property you use to achieve or derive intelligence from the data you collect, when you encrypt that with the keys and send it out of your machine, then you're protecting your core assets. And of course, someone cannot hack your machine and steal your core assets. This is like your intellectual property, your customer data, or acquired knowledge over time. Next, you achieve operational security, meaning you and your customers can achieve uninterrupted business operations because your machines are hack-free. And third and foremost, or one of the most important things these days, is brand protection. Once somebody is hacked, then the recovery of their brand and their brand quality takes a long time. So you achieve business security by protecting your brand and your customers' brands. So with all of that said, please do know that the Nuvoton marketing team and engineering team have been actively developing and designing the next generation solution based on the Cortex M33. The reference design I've talked about so far and the device that's been in production is based on the M23. So the next generation is being designed based on the Cortex M33. It's well in development. And of course, it's going to offer enhanced device features, such as improved power consumption and many device level benefits, as well as solution features specifically targeting enhanced security functionalities so that you can take your designs to the next level of end-to-end security. Thank you very much for listening. And we look forward to you reaching out to get a hold of these reference designs. Thank you.